Good morning, guys. Thought I'd hammer out some of these quick little ones just to see what's going on. So this is Lucky Dice. There were technically only 3 questions, so I may hammer this out in one or I may split this up. We'll see how it goes. Most of this was just review. Make sure you remembered how loops worked. Added a little bit of challenge in the algorithm part because you had to figure out how to calculate or to test for these. But it's all basic math. Get an integer from a keyboard and print all factors of that, factors including 1 and itself. So that's all factors. And so we've got an example of 24 that we can run our code and check with. So let's just jump into it. I'm going to do replit this time just because. So here we go. I'll give my comment because this is number 1. And I'll go enter integer to be factored. And a lot of people have been asking me about this, why I'm putting instructions in here. Well, the examples I've given you where it's like enter an integer, enter a double, enter an integer, enter a double, something like that. Those are just defaults. Okay, the user is by far the second stupidest thing you're going to deal with, the first being the computer itself. So they know only what you tell them. And so sometimes it takes a very precise, specific instructions to get what you want out of them. So yeah, don't be afraid to give any more detail or more instructions or be precise. You know, that's fine. So enter an integer to be factored and int num equals scan a dot next int. Oh, I forgot to do all my inputs. So okay, import java.util. There gets my scanner, which means I also need to create a scanner. There you go. Now we get 1. Now we've got that. Okay. Okay. Factors of num are, and just to match theirs, I can take out the R. There we go. Now I'm going to do this before I jump in the loop because if you notice they're all on that same line. So I can make this a little bit more visible for you guys. There we go. All right, so now I've got my loop. Now I know exactly how many times I want to do it because the user's defining the number. So I just need a counter. I is my default. We'll start at 1 since 0 will never be a factor. I is less than equal to num because that's where we're testing. And then I goes up by 1 every time. Okay, now we don't just want to put a print statement in here. We only want it to print if it's a factor. So we need an if test. So if num mod I, we take the number they gave us and we do modular check on the counter we're at. If that equals 0, meaning it is a factor, then we can print. Okay, and again, I just want to print I, and then I think they had a space. Do they have commas? Nope, just a space. And that's all we need. Now, once that gets done, then I want to finish the line. So this is where I'll come in and put my ln. Just an empty string after the fact, just be like done. That's it. So let's do a check while we're here. And a lot of y'all, again, reminder, check your codes. If it doesn't run, you're not finished yet. 24, factors of 24, 1, 2, 3, 4, 6, 8. Well, yep, we're good. So there's number 1. Okay. Now we got number 2, which is a cool number. Cool number is a number that has a remainder of 1 when divided by 3, 4, 5, and 6. Get an integer from the keyboard and figure out how many cool numbers exist between 1 and n. example they gave is 5,000. So there are 84 cool numbers between 0 and 5,000, or 1 and 5,000. Okay, I gave y'all the test for this. So if, and we had a lot of these. Well, let's get the stuff going first. Okay. We'll call this num2 since this is for question number 2. Enter an integer to check levels of cool. Backwards. Yep. Wrong slash marks. And this is just to let me follow in the code. It's okay. Cool. Enum right there. Okay. So now my for loop is going to check every number. So that's easy enough to code because it's going to be very similar to what we just did up here. And we'll go j this time equals to 1. J is less than equal to num2. J plus plus. Now the if test is where this gets specific because I only want to, well, I'm not even printing, I'm counting. So I need a accumulator variable. We'll just call it count because that's all it is, and we'll set that equal to 0. And I guess we may as well write the if statement. So if I mod 3 equals 1, so that means has a factor of that. Okay, then I give the next one, which would be 4. I include the next one for 5. And the last one, 6. So it has a remainder of 1 if I divide it by all 4 of those numbers. Okay? If that happens, all I want to do is I want to increase the count by 1. That's it. Last thing I need up here is a print statement after the loop, after it's counted everything. There are count phrasing cool numbers up to and I list num2 just like they asked. Okay, that's number 2. Go ahead and check it again. And again, remember word wrap over here. Okay, messed up some stuff. Oh, forgot. I changed my variable. J. Leaving on the network. There we go. We know 24 works. Do just another one just to see. Looks good. Okay, enter an integer to check levels of cool. They gave us 5,000, 84 numbers. We're good. Again, all cosmetic, but we could add spacer lines if we wanted to. This one just easy enough to just do that. And this one will go after here, just so we're ready for number 3. Because number 3, as we recall, is the same thing, only this time we need to write it with a while loop. So we're going to do a lot of copy pasting, but we're going to tweak it ever so slightly to fit in that pattern. So I'll just go ahead and copy the entire thing, and we'll manipulate it as we go. Okay, so this one will now be num3 and count 3 to keep it easy. The number we're on. Okay, so this time it's a while loop. So that means we need an external counter. Int k equals 1. This is going to be a while loop while k is less than equal to num3. Okay. Change these to k. And I'm changing variables just to keep everything separate and straight. If you want to recycle and reuse them, that's up to you, but that's fine too. And then increase count. But then I also need to upkeep k inside the while loop. That way it advances the number. If when we are done, so then we get count 3 and num3, and that should work. So let's take a run at it. Number to be factored, 240. Yep, numbers to check levels are cool. So we know 5,000 worked. Let's go 50,000. Okay, very big jump. This is the one we're testing. 84, we're good there.